Imagine a city facing frequent power outage, and you are the engineer assigned to solve this problem. What will you do? Will you jump into building a new power plant, or will you first consider the population and population growth in next 10 to 20 years and then design the power plant to supply energy based on the present and future demand? I'm Ruin Farzan, a mechanical engineer specialized in thermal engineering and energy systems. Today, you will learn what is an engineering problem, what are different approaches to solve an engineering problem, and how engineers in today's day solve the problems. An engineering problem is any real-world problem which needs scientific knowledge and systematic approach to solve them. And that's how engineers define the problem first, and then they use a systematic way and apply scientific laws to resolve those issues. There are three main approaches to solve an engineering problem. The first approach is analytical approach, the second experimental approach, and the third numerical approach. We first start with analytical approach. In analytical approach, we have pen and paper. We first define the real-world problem, then we transfer the problem into a piece of paper. How we do that? We use mathematical equations and variables to define the problem. Then we solve the equations, we make assumptions, and the result is the solution to the problem. This is a good approach to solve an engineering problem when you want to understand the problem very well and when you want to solve the problem in an easy way. But it has some drawbacks because of the assumptions. So it has a high error. In addition to that, for complex problems and geometries, it is hard to use this approach. That's why we have the second approach, which is experimental approach. An experimental approach, we define the real-world problem, we create a prototype of the problem with a smaller size. We define the forces and other variables the same way the real-world problem is. Then, and we record the data. We repeat the experiment and we modify the design. It is a good approach if you want to get the realistic data which matches the real-world scenario. However, it has some drawbacks as well. It is very costly, and for some problems, it is hard to make a prototype. Therefore, we have the third approach, which is called numerical approach. It is a modern approach, and instead of pen and paper or a prototype, we create a digital version of the problem using CAD softwares, coding, and different ways. Then we discretize the problem. By discretize, I mean dividing the problem into smaller pieces. Then we define differential equations, and by converting differential equation into algebraic equations, we solve the problem. This approach has a higher accuracy as compared to the analytical approach, and it is really cost effective as compared to the experimental approach. However, it has some drawbacks. It needs validation. When we are doing numerical analysis, we need to validate it with experimental results. And we need a very high computational powers. Sometimes it's not available. But for complex problems, it's the best way. I'm specialized in numerical analysis. I have done it for over 6 years, and in this channel, I'm going to help you with that. In today's world, they are not using only one approach. They use a combination of all three approaches. The first, define the problem, use analytical approach. Then they perform some numerical analysis, and then they validate their analysis using experimental approach. Numerical approach helps us modify the problem as much as we want, and we reiterate the simulation as much as we want. That's how we get the optimized design in a very efficient way. Thank you for watching this video. If you want to watch more contents like this, and if you want me to record a series of any subject, comment below